Ladies and gentlemen, in this video, we're going to talk about how to add and subtract with scientific notation. Now, if you didn't see the previous video, we also discussed how to convert from standard form to scientific notation or vice versa, scientific notation back to standard form. So if you want to see that video as well, I'll link it in the description. Now let's go ahead and get into adding and subtracting with scientific notation. For our first 5 questions, we're going to focus on adding with scientific notation only. Then the next 5 is going to be subtraction only. And then we're going to move into a practice session where there's 5 problems for you to try out on your own that are just going to intermix both operations. So for number 1, we are adding 2 and 41 hundredths times 10 to the second plus 5 and 13 hundredths times 10 to the second. And when you're adding with scientific notation, the first thing I always check is look at your powers of 10 and see what the exponent is on each one of them. Your powers need to match. And what's nice about number 1 is that we have a match of 2's. And since we have a match, we are now allowed to go ahead and add our coefficients, which are just simply the numbers out front. So let's go ahead and do that. We have 5 and 13 hundredths plus 2 and 41 hundredths. Notice how I'm lining up the place values. The decimal points are lined up because I don't accidentally want you to shift the numbers in the wrong spot. I'm going to move my decimal point down into my final answer. 3 plus 1 is 4. 1 plus 4 is 5. That decimal point's already there nicely for us. And then 5 plus 2 is 7. So now we have 7 and 54 hundredths times 10 to the second. Now the last thing we need to check and see, is this actually in scientific notation or not? And the way that we check to see is look at your coefficient or the number out front. It has to be greater than or equal to 1, but less than 10. Well, 7 and 54 hundredths is definitely in that range, so this is our final answer for number 1. Now let's go ahead and take a look at number 2. We first check our exponents, and I see another match of negative 4's, which means we can go ahead and add our coefficients right away. So we have 6.1 plus, lining up our place values, our decimal points, but you're going to notice that one of these goes to the tenths place and the other one goes to the hundredths place. To fix that, I'm just going to add in a placeholder 0 there. That doesn't change the value of this decimal at all. It just makes adding a lot easier. So we move our decimal point down into our final answer. 0 plus 3 is 3. 1 plus 1 is 2. The decimal point's there already for us. 6 plus 4 is 10. And we end up getting 10 and 23 hundredths times 10 to the negative 4th. Now, if you look at your coefficient this time around, it doesn't fall in that range that we just discussed. It's greater than 10, and it needs to be less than 10. So we need to adjust this so it's actually in proper scientific notation. So to do that, we can move our decimal point 1 place value to the left, because then we're going to get 1 and 23 thousandths, which then falls in that range, greater than or equal to 1, but less than 10. But we can't just make that change without something happening. So it's going to be 1 and 23 thousandths. If we move our decimal point 1 place value to the left, our power is going to increase. So we just made our number smaller, and in return, the power does the exact opposite and becomes larger. So we end up getting 1 and 23 thousandths times 10 to the, just be very careful with negatives, it's the negative third. Okay, it's increasing or getting closer to becoming positive. So number 2 is done now, and now it's in proper form. Now let's go ahead and take a look at number 3. We have 4 times 10 to the 7th plus 7 and 56 hundredths times 10 to the 8th. But I notice this time around, our powers for the first time are different. So we can't add our coefficients until our powers match. So the easiest way to do this is we always want to change the one that has the smaller power. In this case, it's 4 times 10 to the 7th. So we need to adjust that coefficient by moving the decimal point 1 place value to the left like we just did in the previous one, because in return it's going to increase our power by 1. But 4 doesn't have a decimal point, but it is behind the number if you don't see it. So I'm going to move it 1 place value to the left, and we're now going to end up getting, I'm just going to write it above here, 0.4 times 10 to the 8th. So we made our number smaller, and in return our power increases. So now we can go ahead and add our coefficients together. So let's go ahead and do that. We have 7 and 56 hundredths plus 0.4. I'm going to add in that placeholder 0 there. drop the decimal point down. 6 plus 0 is 6. 5 plus 4 is 9. Our decimal points there for us already. 7 plus 0 is 7. And we end up getting 7.96 times 10 to the 8th for number 3. Now let's go ahead and take a look at number 4. Once again, we have a scenario where our powers are different, which means we need to adjust the one with the smaller power. In this case, it's going to be 8 and 5/10 times 10 to the 8th, but our numbers are not off by 1 this time. They're off by 2, which means we're not going to move the decimal point 1 place value to the left, but now we're going to move it twice. So let's go ahead and adjust that 8.5. So I'll do it below here just because there's writing above it. So 8.5. We're going to move it once to the left, and now it's in front of that 8. But we need to move it one more time so it ends up here. So to fill that empty space, we have to add in a 0 here, and now we're going to get 85 thousandths for this. So now I'm just going to rewrite it in parentheses with the correct power. So this is 0.085 times 10 to the 10th now. Since we moved it twice to the left, our power is going to increase by 2. And now we can go ahead and add our coefficients together. So we have 1.4 plus 0.085. We're going to add in 2 zeros here just so they both now go to the thousands place. We're going to drop our decimal point down into our final answer, and now we can add. So we get 5, 8, 4, 1. And our final answer is going to be 1 and 485 thousandths times 10 to the 10 for number 4. Now we can go ahead and take a look at the last one before we shift gears to subtraction. So I notice our powers are different, but this time around they're off by 3. But we need to be careful here which one is actually the smaller exponent because it's negatives. Well, -6 is technically the smaller exponent because it's further away from being a positive number. So we need to adjust this one so our exponents end up matching. So let's go ahead and change 3 and 7/10. And we're going to have to move our decimal point 3 place values to the left, and in return our power is going to increase by 3 up to -3. So we're going to move it once to the left, twice, 3 times, and then we need to add in 2 zeros into those empty spots. I'm going to rewrite our parentheses up here. We get 0.0037 times 10 to the -3rd. And now that our powers match, we can go ahead and add our coefficients. So we have 7 and 192 thousandths plus, we're lining up our place values here. So we have 0.037. It looks like we need to add in a 0 here. That way they go to the same place value. We drop our decimal point down into our final answer. And now we can add 0 plus 7 is 7. This is 5, 9, 1 decimal points there for us. 7. And our final answer in scientific notation is going to be 7.1957 times 10 to the -3rd. And that's all we have for addition. Let's go ahead and change gears now to subtracting with scientific notation. For the next half, we're focusing on just subtraction. It's going to be very, very similar to what we just did with addition. We're first going to check to see, do our powers match? But instead of adding our coefficients, we'll just simply subtract them. So let's go ahead and take a look at number 1. We have 2 and 84 hundredths times 10 to the 5th. Minus 2 and 13 hundredths times 10 to the 5th. And our powers match, which is nice, so we can go ahead and subtract our coefficients right away. So we have 2 and 84 hundredths minus 2 and 13 hundredths. Again, lining up our place values, our decimal points, dropping our decimal point down into our final answer. 4 minus 3 is 1. 8 minus 1 is 7. The decimal point's there for us. 2 minus 2 is 0. And we get 71 hundredths times 10 to the 5th. Now, once again, we always want to check to see, does it actually meet the standard for scientific notation? Is our coefficient greater than or equal to 1, but less than 10? Well, this is smaller than 1, which means this isn't in the correct format, so we need to adjust this. But this time around, we're going to have to move our decimal point 1 place value to the right to get it in that range. But the problem is if you move the decimal point to the right, or you're making your number essentially larger, the power is not going to increase, but instead it's going to decrease. Again, it's like those opposites. So if you're increasing your coefficient, your power is going to decrease to counter that. So now we're going to end up getting 7 and 1/10 times 10 to the 4th for number 1. Now number 1's complete. let's go ahead and take a look at number 2. Our powers match, which means we can go ahead and subtract our coefficients. So we have 9 minus 5.12. 9's not even a decimal, so I'm just going to fix that by just doing 0.00. Drop our decimal point down into our final answer. 0 minus 2 you can't do, 0 minus 1 you can't do, so we have to borrow from the 9, make it an 8. This is a 10 now, we have to borrow, make it a 9, and now this is a 10. So 10 minus 2 is 8, 9 minus 1 is 8, and 8 minus 5 is going to be 3. So we end up getting 3 and 88 hundredths times 10 to the negative third. It's in that range, greater than or equal to 1, but less than 10. So number 2 is complete, and now we can move our way over to number 3. Now this is one of the ones where our powers are different, so we always want to find the one with the smaller power and adjust that coefficient. And that's going to be the 10 to the negative 10th, so we need to adjust 7.3, and we need to move it 2 place values to the left because it's off by 2, not 1. So let's move it once to the left, then once more. We have to add in that 0 there, and this is going to end up being 0.073 times 10 to the negative 8. So we wanted to increase our power by 2, so we moved the decimal to the left, just like we did with addition. But again, if you need to move it to the right, your power decreases just like you saw in number 1. So now we can go ahead and subtract our coefficients because our powers match now. So we have 8 and 154 thousandths minus 73 thousandths, lining up our place values, our decimal point, dropping our decimal point down to our final answer. 4 minus 3 is 1. 5 minus 7 you can't do, so let's borrow from that 1, make it a 0. We get 15 minus 7, which is 8. 0 minus 0 is 0. 8 minus 0 is 8. And we get 8 and 81 thousandths times 10 to the negative 8th, now that we've adjusted it to be negative 8. Now on to number 4. We have different powers. We look for the smaller exponent. In this case, it's 3.5 times 10 to the third. So we need to adjust this by 1 by moving it 1 place value to the left, so it increases our power by 1. So instead of it being 3.5, we move it once to the left, and we're going to end up getting 0.35 times 10 to the fourth. And now we can go ahead and subtract our coefficients. So we have 1.9 minus 0.35. We're going to add in that 0 there, drop our decimal point down and subtract. 0 minus 5 you can't do. Let's borrow. This becomes an 8. This is a 10. 10 minus 5 is 5. 8 minus 3 is 5. 1 minus 0 is 1. And we end up getting 1 and 55 hundredths times 10 to the fourth for number 4. And now let's go ahead and take a look at our last one before we move on to the practice session. So our powers are different. I see that we have a 6 that's smaller, so that needs to be adjusted by 1. So I'm just going to write the adjustment above. That's going to be 0.4153 times 10 to the 7th now. And now we can go ahead and subtract these. So 7 is not even a decimal, so I'm going to do 7.0000, so it lines up with our other decimal. So 0.4153. We're going to subtract here, drop our decimal point down. We can't do 0 minus 3, can't do 0 minus 5, can't do 0 minus 1, can't do 0 minus 4, so we borrow from the 7, make this a 6. This is now 10. We borrow. There's going to be a bunch of borrowing in this problem. Now we can do 10 minus 3, which is 7, 9 minus 5, which is 4, 9 minus 1 is 8, 9 minus 4 is 5, 6 minus 0 is 6, and we're going to end up getting 6.5847 times 10 to the 7th for number 5. Now let's go ahead and make our way over to the practice session. All right, it's time for the practice session. Do you have what it takes to go 5 for 5? I want you to write these problems down on a sheet of paper, pause the video, and see if you can solve them from start to finish. And when you think you're ready, come back and play the video and see how you did. So I'm assuming at this point you've paused the video, you've tried out all 5, and you're ready to go over the answers. So let's go ahead and take a look at number 1. I checked my exponents right away, and our powers match, which means we can go ahead and subtract our coefficients immediately. So we have 9 and 23 hundredths minus 4 and 7 tenths. We're just going to add in a 0 at the end there, so they're at the same place value. Drop our decimal point down and subtract. 3 minus 0 is 3. 2 minus 7 you can't do, so we have to borrow, make that an 8. This is a 12. 12 minus 7 is 5. 8 minus 4 is 4. And we end up getting 4 and 53 hundredths times 10 to the negative fourth for the first one. So if you got that right, very, very nice job. Let's go ahead and take a look at number 2 now. I notice that our powers are different now, which means we need to adjust the one with the smaller exponent, which should have been 6.5. So to rewrite this, it's going to be 0.65 times 10 to the fifth. If you move the decimal point to the left, your power is going to increase. You're essentially making your coefficient smaller, and in return, your power increases. So now we can go ahead and subtract our coefficients. We have 3 and 2 tenths minus 65 hundredths, adding in that placeholder 0 there. Drop our decimal point down. 0 minus 5 you can't do, 2 minus 6 you can't do, so we borrow. That's a 2. This is a 12, borrow again. Now we can do 10 minus 5 is 5, 11 minus 6 is 5, and 2 minus 0 is 2. And we end up getting 2 and 55 hundredths times 10 to the fifth. Now on to number 3. It looks like we have an addition problem this time, but our powers are going to need to be adjusted by 2, but they're negative. So the smaller one is actually negative 11. So we need to adjust our coefficient by moving the decimal 2 place values to the left, so our power in return increases by 2. So up top is going to look like this now, 0.07 times 10 to the negative ninth. And now we can go ahead and add our coefficients. 8 and 135 thousandths plus 0.07, adding in a 0 at the end there. Drop our decimal point down, and now we can go ahead and add. So we get 5, 10, carry the 1. This is a 2. 8 plus 0 is 8. And our final answer is 8 and 205 thousandths times 10 to the negative ninth for number 3. So hopefully you didn't accidentally subtract those coefficients. Sometimes when you start to intermix them, students just get confused and accidentally subtract when they should have added. So now let's go ahead and take a look at number 4. Looks like our powers need adjusted once again, so we need to fix 1.4. So that's going to become 0.14 times 10 to the third. And now we can go ahead and subtract these. So 2 and 86 hundredths minus 14 hundredths. Drop our decimal point down. 6 minus 4 is 2. 8 minus 1 is 7. 2 minus 0 is 2. And we end up getting 2 and 72 hundredths times 10 to the third. And then finally, the very last one, we have powers that match. So we can go ahead and add our coefficients immediately. So we get 6 and 34 hundredths plus 5.00. Drop our decimal point down. We get 4, 3, 11. And we have 11 and 34 hundredths times 10 to the seventh. The only problem is that our coefficient is not in that range that we discussed earlier. It's not greater than or equal to 1, but less than 10. It's larger than 10. So we need to make an adjustment by moving the decimal point 1 place value to the left so it meets that range. So our coefficient's actually going to be 1 and 134 thousandths times 10 to the, and then again, if you move the decimal point to the left, the power increases. So this should be to the 8th. That's all we have for adding, subtracting with scientific notation. If this video helped you out, leave a like on the video, comment any other topic you want to see in the future, and make sure to subscribe, turn on that bell for post notifications when the next video releases, and we'll see you in the next one with some more mathematics.
Sorry, baby, I just don't know the words. Was it really past 10?